Thanks for dropping in. This channel is best known for 3D printed puzzle boxes, satisfying fidgets, and mechanical toys. But for a while, I've wanted to add another category to the mix: teaching aids and other educational models. This video is a test in that direction. I hope you'll excuse me for venturing a bit from my usual focus, but don't worry, more typical 3D printing designs are in the works. This is a tactile, triangular teaching tool. The adjustable triangle can be used to demonstrate a range of geometric concepts, but I designed it specifically with triangle congruency theorems in mind. You might remember this from 8th grade geometry. If two triangles share specific attributes, those triangles as a whole are congruent, or identical. The simplest example of this is side-side-side congruency. It's fairly clear that if two triangles have three sides with matching lengths, then those triangles will also have matching angles. If I lock the length of each side of the model by tightening these three dials, I can physically demonstrate that it's no longer possible to squish or pull the triangle into any other shape. Well, not without extreme measures, but that's best handled in physics class or non-Euclidean space. On the other hand, if we were to lock only the corners of the model, a wide range of potential triangles can still be produced. Therefore, congruency can't be assumed. Multiple non-identical triangles can share matching interior angles. This physical test of locked attributes can be applied to all the triangle congruency theorems. For some students, this can turn a series of seemingly arbitrary rules into a concrete demonstration. But this is just one scenario. The tool could be used in many other ways. For example, to demonstrate the various types of triangles. Or colored segments might be able to help when discussing the relationship between the length of one side of a triangle with its opposite corner. While I wouldn't leave this print alone with a toddler, my 2-year-old nephew spontaneously created a quiz show as I rescaled an equilateral triangle. Is it a big triangle or a small triangle? Was the most fascinating question in the world for more than 15 minutes. To support all these different uses, the model has a few customization options. First, it comes in two scales: a larger size that has 120 millimeters of travel, and a smaller variant that has half that movement. The side length is the only difference between these sizes, so you can mix and match parts to create more extreme triangles. The dials rely purely on friction to lock parts in place, but it is possible to force a locked angle to slip. If that's an issue, the model includes a click variant. These clicking parts have registration grooves carved right into the model for stronger locking. The only downside is this will limit you to specific side lengths and corner angles. And finally, the dials themselves come in a large, easy-to-grip option, or a smaller variant that's better if you want to use the tool for tracing. Regardless of the customization options you choose, assembling your own copy is easy. First, we'll lock together the upper and lower tracks of each triangle side. The track pairs clip together with a little force, like this. Make sure that you line up these parts correctly. The pointy ends of each bar will be in the center of the linkage, while the rounded ends will face outward. Now connect these paired tracks into a triangle, and finally, cap off the 6 threaded posts with loosely secured dials. Don't over-tighten these, they just need to be on well enough to avoid slipping off. For this print, I used larger dials for locking the corners, and smaller dials for locking the sides. Use whatever looks best to you. If all is assembled correctly, the triangle should easily shift between various configurations. This model, and all my future educational designs, is shared under a Creative Commons public domain license. That means that you can print it, modify it, repost it, sell copies of it, or do nearly anything with it for free, and with no requirement to credit the source. I hope to build up a large collection of these 3D printed educational projects. Ideally, I'd like to create one educational model every month or so. usually in addition to my current output. But there's one big problem. I have no idea what designs would be most useful. There's not much point in designing something if it's not serving a purpose. So if you're a teacher who has a specific model need, let me know and I may be able to design something for you when the next project slot is available. I won't be able to fulfill every request, of course, but I'll take on models that I know are within my ability and aren't covered already by existing designs. I'm open to creating designs for any subject, but my expertise definitely fits more in mechanical and abstract designs. Modeling a realistic-looking cutaway of a human heart is not something I'm likely to excel at. Feel free to make those requests in the comments section below or email me. My most current contact information is listed on 3dprinty.xyz. I look forward to seeing what projects this inspires. But until then, happy printing, and thanks for stopping by. Even when I'm trying not to design a fidget, I design a fidget.